Hi, I am Golani from the Tshwane University of Technology. I'll be presenting with Mutadi, also from TUT. We are presenting a virtual technical training application done by 4 colleagues from TUT and 2 others from the University of Khartoum, Sudan. Over to you, Mutadi.
Thank you, Kolani. As you can see, the image shows a TVET College workshop where there are challenges with high cost of energy, material disposal, and maintenance during training. So reducing training time can lower these costs and allow more time for tasks requiring critical thinking. The solution is a virtual reality based technology training software. It runs on head mounted display and desktop but performs better on HMDs, which are head mounted display. Allows the user to move in 6 degrees of freedom. As you can see, bending, grabbing, carrying, positioning, and all natural motions. Common digital training methods are done on desktop platforms with limited imaging and less natural modes of interaction. To effectively deploy the solution across TVET colleges in South Africa, we need partnerships with the Department of Higher Education and Training.
Our solution minimizes reading errors by making use of color and other visual cues. It increases the user's sense of presence through head tracking, allowing walking and bending. It provides easier user modes of interaction, enabling complex actions such as grabbing and other movements seen on the previous video. The image shows use cases or learning outcomes that were intended, but not all of them were built into the prototype we are about to present. So, our prototype shows the user how to use buttons on the controller. The environment that is mimicked is a training center in a railcar manufacturing factory. The user is prompted to choose between learning and assessment and is allowed to view the environment and walk to any location of choice. The user then receives an instruction to proceed to the workstation using an audio and visual cue. The user sees a highlighted part on the table and is expected to grab the part using the controller seen as a hand in the virtual environment, and then the system shows the user where and how to position the part on the jig using the blue highlight. The user can also orient the part using both hands. The same process happens until all parts are assembled. Then the system will prompt the user to select assessment once done assembling, and then during assessment there is no instruction and the assembly time is recorded to monitor the user's performance.
Our solution reduces training time, error rates, energy, material, and machines maintenance costs for technical training providers. And it also expands the virtual infrastructure that enables training on resources that are not available. Lastly, this solution bridges the gap between the industry and academia using technology that imparts hands-on assembly skills in preparation of graduates that are ready for work. The project will be completed in a year and it will consist of 6 modules, which are diesel mechanic, boilermaking, electrician, fitting, and millwright. The task highlighted in yellow will be done for all the modules. However, due to the limited time we had, we omitted the feasibility study and the evaluation phase. The feasibility study is where we engage the management and the learners to understand what matters to them and where to start and the expected benefits. The evaluation phase aims to ensure that the solution is really working for the customer, and these phases are our differential strategy.
So we have designed our interface to allow the learner to log in. Before logging in, the learner has to register, and this is the registration page. And then during training, the learner can choose which part they want to weld on this interface. And then we also have an interface for the trainer where the trainer can specify the assembly sequence for each part and then link each jig to a part and then also specify the assembly time of that part. So we intend on spending the price on traveling costs incurred during system development, paying incentives for engineers who are developing the system, providing internet data to remote software engineers, and lastly, marketing the application to the manufacturing industry. Thank you, and hopefully you will invest in us.